I'm He Yan. I'm the founder and president of Solarbe.
Audience, I'm Huang Qiang, and it's my pleasure to be the moderator today. First speaker, Dr. Martin Green from UNSW. He's gonna talk about how close we can get to 29% cell efficiency.
So as mentioned, I thank you for that introduction, but I'm Martin Green from UNSW. But what I'd like to talk to you about tonight is how close can we get to 29% silicon cell efficiency? And the answer from my point of view is very close. We both got very similar answers. So for 150 micron thick cell, we calculated, both of us, 29.7% efficiency. And even though a lot of the parameters have changed in the intervening 40 years, a modern calculation still gives a very similar value, 29.5, as you can see on the graph there in the background.
Dr. Andreas from lich. Today his topic is heterojunction solar cell technology development.
Shows the increase of efficiency records for silicon heterojunction solar cells in the last 2 years. This increase of the efficiency was enormous. Just in October, the latest record, as Martin Green already said, was set by Longi of 26.3%. This increase in the recent year was partly related to the fact that the solar cell producing companies stepped into the silicon heterojunction solar cell production. Our partner institute, the Helmholtz-Zentrum Berlin, just released a new efficiency record of 29.8% for perovskite silicon tandem solar cells.
To give the stage to Dr. Rose. And today he will talk about IBC cells, technology development and trends.
I'm going to be talking about those products and actually what is Maxeon Solar Technologies and some of the products that are new or under development, and then some discussion of development for high reliability. Some quick thoughts on design for reliability. Sharing them because one is we're proud of what we've done, but also we don't want there to be any major reliability problems in the industry. And second reason is these cells are ideal for 3 or likely 4 terminal tandems. So if this helps somebody develop stable, really reliable, high efficiency, then it could have value to us. But it has to have those very high reliability.
He is the head of Department Production Technology, Surface and Interface at the Fraunhofer ISE in Germany.
The major challenges currently also for the industrial implementation is, of course, how to manufacture and how to produce the polysilicon layers. For that, we have, let's say, different options to deposit this polysilicon layer at the rear. Of course, the classical path, which is also, I think, the one which is mostly implemented in industrial lines, is by low pressure CVD techniques. But for scale up in production capacity, really in the heavy gigawatt range, this kind of abundancy will definitely then, of course, become relatively important, as it can be seen here. I mean, it's a similar graph you can draw up also for heterojunction because you have exactly the same case. And originally, this graph also was made for heterojunction.
Once again, thank you to all the speakers and audience. It's really insightful sharing. And thanks Solarbe for making this discussion possible. And looking forward to you on the next session on perovskite, which will be go online very soon. Bye.
Goodbye.
Goodbye.